Hi everybody, welcome to another video in Trigonometry, section 9.3. We switch gear a little bit from the trigonometry. We just focus on complex number in this section. So, review. First, we define square root of -1 as the imaginary I or imaginary unit. So I is equal to square root of -1. Or I square is equal to -1. Next, a complex number is a number will take the form of A plus BI. A is the real number, B is also real number, but the A by itself is called the real part of that complex number, and B attached to I is called the imaginary part of the complex number. If A equal to 0, we just have BI, which is purely imaginary. And if B equal to 0, then we have a real number. In general, if we have, for any positive number B, square root of a negative number, we'll take the negative inside the square root, turn into the imaginary I, and then we just have square root of B. And two complex numbers are equal if the real parts are equal and the imaginary parts are equal. Now, in terms of operation on complex number, it will be easy, just like operation of numbers. If we can treat I as a variable, almost, then we can just do like that. So when we add them, combine like terms, A plus C, those are reals, and B and D imaginary parts, so we combine like terms. So just treat I as a variable and combine like terms. So we can add or we can subtract, same thing. Now product. If A plus BI is a number and C plus DI is another number, when we multiply them out, we just distribute it and multiply, just like multiply polynomials. Now, so that's exactly the same. The only thing different here is, by definition, we have I squared is equal to -1. So in this case, we have AC times -1 times BD. So in this case, I can rewrite this as AC plus AD times I plus BC times I minus BD. Combine like terms, the real parts together and the imaginary parts together, factor out an I. That's what we have. So that's nice and all, but we don't even need to know that. We don't even need to memorize all of this. We just do it like we normally do if we treat I as a variable. So Z is 2 minus 3I, and then plus W 4 plus I. Remove the parentheses, and then combine like terms. 2 plus 4 6 minus 3I plus I minus 2I. Simple enough, right? Now Z times W, Z 2 minus 3I, W is 4 plus I. Now multiply it out. 2 times 4 is 8. 2 times I, 2I. Minus 3. I times 4 minus 12I. And minus 3I squared. Now, I squared is -1, right? Yeah, we should just combine like terms here, but yeah, I square is -1. Now combine like terms. That gives us -10I, and then 8 minus -3, so 8 plus 3 is 11 minus 10I. Right. If we're using the TI calculator like this, we can use that to do complex number. Make sure that hit mode and we go to, if it's not real, go to a plus bi, which is in the complex mode. So a plus bi, highlight. Now it is in complex mode. We can just do the math here. 2 minus 3i. The imaginary I is above the decimal point, so we hit second. So 2 minus 3i times 4 plus I. Yeah, so that's what we have. Of course, we can subtract them too, or we can add them. That's 6 minus 2i. So simple enough, right? Next, negative iz plus 2w, so negative I z 2 minus 3i. So we treat I as just a variable, multiply it out, combine like terms. If we see I square, that is negative 1. So simple enough. 2 times w. Right, multiply it out, negative 2i. Negative times negative is positive, 3i squared plus 8 plus 2i. Well, combine like terms, we cancel out, and I squared is negative 1. I squared is negative 1, and that gives us 5. So negative I times 2 minus 3i plus 2 times 4 plus I. And we have just 5. So simple enough, right? Yeah. Just treat I as a variable. If we have I squared, that is negative 1. So I squared is negative 1. I is square root of negative 1. So what is I cubed? I to the 4th, I to the 5th. What is the higher power? So, and now, of course, I'm going to answer that, but let's just write out what we know. By definition, anything that is not 0 raised to 0 power is 1. I to the first power itself. I square by definition is negative 1. Now what is I cubed? I cubed, of course, is going to be I times I square, or I square times I. I square is negative 1, so we just have negative 1 times I, or negative I. So that is I cubed. How about I to the 4th power? I to the 4th power, we can just take I times I cubed, or I square, or I square times I square. So negative 1 times negative 1 is 1. Right, I to the 5th, we can write as I to the 4th times I. I to the 4th power is 1. We just did, times I. So this is I. Now, if we keep going, you will see this pattern that I to the 6th is negative 1, and I to the 7th is negative I. And this cycle will repeat in the cycle of 4. So 1 I, negative 1, negative I, 1 I, negative 1, negative I. Just keep going like this. If we just keep going like this, when we go to I of 100, we see that 100 is divisible by 4. So this is, it's just equal to I to the 4th, which is equal to 1. Okay, let's see if it works like that. Yeah. Okay. How about I to the 25th? Right, 25 divided by 3, the remainder is 1. So in that case, this is the same thing as I to the remainder. By the way, we could say this I to the 0 power is fine. So when we raise I to any power, we just take I raised to the remaining when we divide by 4. So I to the 25th is the same thing as I to the first, because 25 divided by 4 is the remainder is 1. Right. What we see is the negative 5 times e to negative 13. This is a very small number. So essentially we just have I because this is 0, very close to 0. Right. So when we have I raised to anything, just divide by that number by 4 and raise to that remainder. So I to the 4 is the same thing as I to the 0 power. I to the 5th, same thing as I to the 1st. I to the 6th is I square. I to the 7 is I cube. And then we so on. Yeah, just raise to the remainder power. Right. Now we can add, we can multiply. Of course, we can add, we can subtract, we can multiply. How do we divide? Right. In order to divide, we have to define one thing that is called the conjugate, complex conjugate. So if a number is z, the conjugate of that is denoted by z bar. We draw a bar on the top of it. So what we have here is the conjugate of a plus bi is a minus bi. So what we do in the complex conjugate is that the real part will stay the same. Real part is unchanged. It's the same. So A and A. And imaginary part are opposite. So now when we multiply them out, I'll just write that out and we'll do combined like terms. We'll see what happened. So a plus bi, a minus bi, multiplied out, a times 8, a square, minus abi, plus abi, minus b square, I square. Because the middle terms cancel out, because combined like terms, I square is negative 1. So we have a square minus b square times minus 1. So a square plus b square. Pretty much. So that's what we have. And when we define the complex conjugate, we can define the quotient. So if we divide them, we multiply the complex conjugate top and bottom. So that's how we divide them. Just multiply by the conjugate. So we don't divide, but we multiply by the conjugate. Right. Let's see how it works. In math, I think we go to here, complex conjugate. Let's say 2 plus 5i. Yeah, that works. So math, we'll do add option complex, and we'll do all of that. So first, the complex conjugate of z of 2 plus 5i. So we have 2 plus 5i. Complex conjugate of that. The real part will stay the same. The imaginary part will change the sign. So that's all, right? Next, what is w times the complex conjugate of w? So we have 3 minus 2i, and that's 3 plus 2i, but I'm just going to put this for now. Conjugate of this real part will stay the same. imaginary part, we change the sign. Multiply it out. 3 times 3 is 9. Plus 6i minus 6i minus 4i squared. I squared is negative 1. 6i cancel out. So 9 plus 4 is 13. In the next section, we will study some significance of W times W bar. But for now, that's all we do. Right, divide. We cannot really divide them, right? We can multiply by the conjugate, top and bottom. Yeah. I just put the numbers here. W 3 minus 2i. Z 2 plus 5i. Now we cannot really divide, but we can multiply by the conjugate. 2 minus 5i. 2 minus 5i. The conjugate of the denominator. This is 2 plus 5i. That will be 2 minus 5i. Now, just multiply them out. Combine like terms. Right, the top. 3 times 2, 6. Minus 15i. Minus 4i. Plus 10 I squared. 2 times 2 is 4. 2 minus 5i minus 10i plus 10i minus 25 I squared. Right. So I squared is negative 1, right? So that minus 19i. And I squared is negative 1, so which is minus 10. The bottom, when we multiply the conjugate, the middle terms cancel out. So I have 4, I squared is negative 1, so it will be 4 plus 25. So we have minus 4 minus 19i over 29. We should split, so we can write the answer as negative 4 over 29 minus 19 over 29. The reason we write like this, so we have the real part and the imaginary part separate. Right, now if we do this using the calculator, 3 minus 2i divided by 4, 2 plus 5i. And if we convert this to fraction, hit math, convert to fraction, we have negative 4 over 29 minus 19 over 29i. Yeah, so we should give the answer in the complex number with the real part. Give the answer in complex number with the real part and the imaginary part. Right, next, z divided by the conjugate of w. Z 2 plus 5i. The conjugate of w is 3 minus 2i. Let's just say conjugate of 3 minus 2i. So 2 plus 5i divided by 3. Conjugate of 3 minus 2i is 3 plus 2i. Yeah, real parts stay the same. Imaginary part turn to opposite. So 3 plus 2i. 3 plus 2i. Yeah. Notice that we must, this should be minus, right? Wait, that is a conjugate. So remember, what we multiply by is the conjugate of whatever the denominator is. So in that case, we multiply by 3 minus 2i. Yeah. So the conjugate of 3 minus 2i, 3 plus 2i, we multiply by the conjugate of that, which is 3 minus 2i. Now multiply it out. Of course, now we get used to it. We can just skip a few steps, but I just multiply them out. 2 times 3 is 6, minus 4i, plus 15i, minus 10i. Square, sorry. 3 times 3 is 9, minus 6i, plus 6i, minus 4i squared. Right. I squared is -1, so we have 6. That is 11i, compile like terms, and minus 10i squared, that plus 10, because I squared is -1. As always, middle term cancel when we multiply by the conjugate. 9 plus 4i, -4i squared, I squared is -1, so that 9 plus 4. So we have 16 plus 11i over 13. And we split, so we have the real part plus the imaginary part times I. Right. So let's see. We have 2 plus 5i divided by 3 plus 2i and convert to fraction. Yeah, that's what we have. Right. By the way, when we're done with the complex number, make sure we go back and change this to real number, because otherwise, if it is in complex mode, it will do some strange thing. Right. So, anyway, in this case, in this section, we just study about complex number and how do we do operation of those complex numbers. In the next section, we incorporate some trigonometry into the complex number, but that's all we do in this section. Thank you for watching, and see you in another video in trigonometry.